Okay, so we are going to continue with the subject matter of interrupt. So what we have actually seen before is on how to actually configure interrupt. So we're going to continue with that. So we'll take another example. So now let us look at this example. So now we are actually looking at how to actually set up or configure the interrupt. That's what we're actually doing. So let's look at this example. So write an instruction sequence to configure timer 1 as high priority interrupt. Now remember what is the step flow that we actually going to do. What is the first step? The first step is we're going to identify our interrupt source. So timer 1 is our interrupt source. What is step 2? Step 2 is identifying which group does this belong to. So if you recall correctly, the core group is actually consist of INT0, INT1, INT2, INT3, port B pins change, and also timer 0. So this is now is timer 1. So that means it belongs to the peripheral group. So it's not the core group. Okay, so this is the second one. So the third thing that we want to do is we want to configure the all the control bits, right? So let's start writing the code. So the first thing that we actually want to do, let me see where is the space that I can write the code. Make it smaller. Okay, I'll write here. So what is the first step? The fourth one. Because here it mentions that it want high priority interrupt, right? So we have to always configure the RCON, IPAN bit from RCON. So what we actually want to do, we always want to bit set F, RCON, IPAN. This is standard. So what this will do, this will actually enable the interrupt. Sorry, not enable interrupt. It will enable the priority levels. Priority level. Sorry, my handwriting got a bit bad. So this is on bit set. This enables priority. So we have priority level because it has to do high priority, right? So we have to enable the IPAN from RCON. So this will enable the priority levels. The next thing that we want to do is we want to configure the three control bits of timer 1, which is flag, enable, and also priority bits, right? Now because this is peripheral, you will look inside these registers. PIR always consists of flag bits. PIE always consists of enable bits, and IPR always priority. So you can use to remember this, like PR means is priority, IE means enable, IR, of course you don't see the word flag, but PIR is actually all the flag registers. So you can see that there's only all flag bits only. So it's not unlike INCON where you can see top here you have enable bit, then you have flag bit, so it's all jumbled up. But for peripheral you have to look at the PIR, PIE, and IPR. So that's why it's important for us to identify which group it belongs to, so that we know where to search for these three control bits. So now let's try to do what we always want to do with the flag. We must always clear the flag, right? So bit clear F. Now where's the flag bit? Now PIR, there is PIR 1, PIR 2, PIR 3. So you have to search in each one of it. So do we see any timer 1 flag? Yes, we see it here. Timer 1 IF flag, right? So it is in PIR 1. Now here's one hint. If the flag, timer 1 flag, if it's in PIR 1, then the enable bit and also the priority will be automatically in PIE 1 and IPR 1. So that's just a hint for y'all. So let's do this. We want to clear the flag. This is in PIR 1 and you want to clear timer 1 interrupt flag. What do you want to do with the enable? We always want to enable, right? Enable the interrupt. So it's PIE, so you can see it's also in PIE 1. So this is in PIE 1, timer 1 IE, timer 1 enable. Then finally what we want to do, priority, priority depends. If it's high priority, then you have to set to 1. If it's low priority, we clear. So here you're asking for high priority. So bit set F, where's the priority bit? Is in IPR. And you can see timer 1 priority is also here. So IPR, priority 1, timer 1, IP. Okay, so we have done this. Now, what we have actually done here is only the local enable, right? We also have to do the global enable. Which bit that is global enable? Which is this one, right? GIEH. So what we have to do, maybe I'll just continue down here. So we want to bit set F in con GIEH, because this is the global enable, right? This is global, GIEH, global enable bit. But are we done? No, because for peripheral there is another bit that you need to configure. Do you see this one? PEIE. So this one is actually enable all peripheral interrupt. So in this case, because we are actually working on peripheral, so we also have to do this bit set F in con PEIE. So this will enable all peripheral. Enable all peripheral. So what is the summary that we have seen so far in terms of this local and global enable? For high priority, we have seen that for high priority, and if it's the core group, if it's high priority, you have 2 levels, local enable and global enable. Only 2 levels, only 2. Let's say if it's low level and it also belongs to core group, you have to enable the local, you have to enable the global. Global means this is global all, the GIE, and you also have to have the global low, which is GIEL. So you have 3 levels. Likewise, now another combination is peripheral. Peripheral interrupt, regardless whether you have high or low priority, you will always have 3 levels. So you'll have the local, you'll have the global, and you have, this is global means the GIEH, and I have no space here, that's why. And this one will be global peripheral. So 3 levels. So if you have understood this framework, then you can configure any interrupt. So this is the flow. Is that okay? So now let us see some example on how we can actually do this. So this is actually one question. So referring to figure 2, write instructions to configure switch 1, switch 1 as low priority interrupt and switch 2 as high priority interrupt. So in this example, we can see that there are 2 switches. So if you look here, this is RB1 and RB2. But remember that each one of this, in the parallel input output port chapters, we have seen that you can either use it as a digital input output pin or you can use it as a interrupt. So either one of the function you can use. So in this case, we want to configure this as an interrupt. So what we actually have done so far is we have seen how to configure the interrupt, the steps. So you just follow the steps, identifying which group it belongs to, and then you identify, the first thing is you identify what is the interrupt source, then the second one is you identify which group, then the third thing is actually you want to do the configuration of the control bits, right? And then we see the 2 levels of enable and 3 levels of enable. That's it, if you are able to do that. So the next step that we are seeing now here is, remember that the interrupt, we can actually have 2. One is external interrupt. Another one is internal interrupt. So external interrupt means this interrupt is actually caused by switch. So the switch, when you press, there is a change of logic, right, from logic high to logic low, right? So this change of logic will trigger the interrupt. So this is what example of an external interrupt. So we look external interrupt. Later we will see in the chapter timer how we can actually have an internal interrupt. So now first and foremost, let's try to see how we can actually configure this. All right. So the first thing that we want to do is identify the interrupt source. So here it didn't mention the interrupt source, but it mentions switch 1 and switch 2. So if you look at switch 1, where is it connected to? INT1. So this is INT1. And where the switch 2 is connected to? Switch 2 is connected to INT2. So this is your interrupt source, interrupt 1 and interrupt 2. So the first step is identify interrupt source. What is the second step? Identify the group. So this belongs to the core group, right? And the third thing is you want to now configure the flag, enable, and also the priority bit. So now when we actually want to write the code, what's the first thing that we want to do? Because here there is the priority levels, right? So by default you have to enable the RPAN of IPAN of RCON. So the first step is bit set F RCON IPAN. So this enables the priority level. Done for the first one. So because now we have two interrupt source, so let's do one by one. So let's do for interrupt 1 first. So we always want to clear the flag. So let's say we have the flag, enable, and also priority. Let's see, we always want to clear the flag, right? Clear flag. Now because interrupt 1 is in core group, so let's try to search. So now we're actually looking at, so we try to search for interrupt 1 flag bit. So let's see under incon. Do we see, is it there? Nope, it's not there. Let's see under incon 2. Why we're searching under incon 2, incon 3? Because for core group, all the flag, enable, and priority are within these 3 registers. So let's search in incon 2. Do we see interrupt 1? No, we don't see. How about incon 3? Yes, it's here. Interrupt 1 flag, it's here. So it's in incon 3. So what we want to do, we want to clear. So this is in incon 3, and we want to make sure we clear the flag. And what we want to do with the enable, we always want to set. So where is the enable bit? Is also in incon 3, and priority bit also in incon 3 here. Okay, all are in incon 3. So incon 3 INT1 IE, we want to enable it. Then what we want to do, the priority. So interrupt 1 is supposed to be low priority. Low priority means we want to clear, and just now we already saw that the priority bit is also under incon 3. So interrupt 1 priority. Okay, so we have actually done with the configuring of these 3 bits. So we will do the global later because we have another interrupt configuration to do as well. So we have done with this is flag, this is enable, this is priority. So the same thing we want to do here, flag, enable, priority for interrupt 2. So what we want to do, the flag, we always want to clear. But now where is interrupt 2? So let's try to search interrupt 2. Where is it? Interrupt 2 flag. Yeah, here. Interrupt 2 flag is here. And let's see, interrupt 2 enable bit is also here. Interrupt 2 priority bit is also here. Okay. So all are also in incon 3. So incon 3. We want to clear the interrupt 2 flag. We want to set incon 3 interrupt 2 enable bit, and this one is high priority, so we want to set incon 3 int2 IP. So done. Now regarding the global enable, so how many priority levels we have? We have low priority and high priority, right? So if it's only high priority, then we would have just 2 levels of global enable. But because now low priority is also involved, so we will have 3 levels. So that means we need to global enable incon GIEH. So what this means, it enables all interrupt as well as high priority interrupt. So which means this interrupt 1 will start working when it sees this instruction. But for interrupt 2, my bad. Interrupt 2 will start working because interrupt 2 is actually high priority, right? Not this one. Interrupt 2 is high priority because here is high priority, right? So interrupt 2 will start working. Okay, when we execute this line. But interrupt 1 will not work yet because this is enabled to low priority. So what we actually have to do, we also have to enable the low priority interrupt, global GIEL, global interrupt enable low. Then only this interrupt will start. What am I doing? This interrupt will start working. My bad. Then only this interrupt will start working because this is low, right? Bitsit F. So through these instructions, now we have enabled all and the interrupt will work. Okay, so there is another question below also, I think. You can see here, study the interrupt instruction sequence given below. The instruction sequence is to configure interrupt 0 and enable its interrupt. Analyze why the interrupt is not working as intended. Okay, so let's try to see line by line. So let's see the first line. So bit set F archon IPEN, correct? So this is actually enable priority level. So this is correct. Let's see the next one. This is bit clear incon enable. So here's the first mistake already. You're clearing. So this is supposed to be bit set F. You're supposed to enable. Let's see the next one. This is incon flag is clear, so this is correct. Then this one bit set F GIEH is correct, but GIEH is not in incon 2. It is in incon. So these are the corrections. So we have 1, 2 corrections that are here. Okay.